Hello students, welcome to my channel SDK Pathshala. Today we are going to discuss something about chemical effect of electric current, or on this chapter chemical effect of electric current we will discuss the effect of electric current or the chemical effect of electric current. That means when electricity is applied or electricity is passing through something, how chemical or what chemical effect occurs there. So before going deep into the chapter, we will need to learn something, that is we will need to know conductors. So as we know, the conductors are the substances which can conduct electricity, or there is good conductor, there are bad conductors. So what do you mean by good conductors? Good conductors are the conductor which conduct electricity easily. So what are the things that conduct electricity easily? Generally metal conduct the electricity easily. So for example, suppose you are not supposed to touch any electrical appliances when your hand is wet with water. Why? Because you may get shock. So is water is a conductor of electricity? Actually, if you say pure water is a bad conductor of electricity. Pure water is a bad conductor of electricity. So why we are not allowed to touch any electrical appliances with our wet hand? So because we can get shock. So as water is not pure, there, because water is mixed with lots of mineral, lots of salts are there which ionize on the water, and that ionization generates the capability for that water to conduct the electricity. Okay, so pure water is a bad conductor of electricity. So if you take some pure water, pure distilled water, and if you try to pass electricity through it, you will see that you will not get that electricity. Suppose there is a or if we mix some amount of salt into that particular distilled water and then put the electricity there, then it will make the circuit a closed one, and it will surely conduct the electricity. So this is the preliminary concept of chemical effect of electricity. So next we need to know about test of current flow. Test of current flow means, suppose current is flowing through a particular conductor. So how will you understand that the conductor conduct the electricity? When you touch that conductor, or if you put a particular bulb, that is LED bulb, into that particular conductor or that particular circuit, then if it glows, then you can easily identify that the circuit is conducting. Okay, like the tester is often used to see whether there is a current flowing or not. Generally it conducts, or generally it closes the circuit. So that's why in a circuit, when you place it, so as current pass through it, then we can tell that the conductor is passing electricity, or electricity is passing through the conductor. Next, there is a particular device that by magnet you can also get to know that electricity is flowing through a particular conductor or not. Suppose there is a battery, okay, and suppose there is a cell. Now if you connect the cell through a particular wire, and if you place a magnet over there, now suppose there is a switch, so on off key is there. Suppose there is a on off key. Now if the key is open, then you will see that there is no deflection on that magnetic compass. Okay, now if we put the key back there, then it will complete the circuit, and you will see there is a deflection on this magnetic needle or needle of the magnet, that is the compass. Okay, so this is the way by which you can identify whether electrical circuit or whether electrical conductor conduct electricity or not. Next, we need to know something about anode and cathode. What do you mean by anode and what do you mean by cathode? So the electrodes are generally conductors which are connected to the positive end and the negative end of a particular cell. So in a or particular battery, so the positive end is connected with one and negative end is connected with another. So this one is positive and this one is negative. Okay, so the positive one is known as, or positively charged, or with the electrode which is connected through the positive end is known as anode, and which is connected through the negative end is known as cathode. Okay, so one is anode and one is cathode. Okay, now we need to know about electrolytes. What are electrolytes? Electrolytes are the substances which conduct electricity in molten state or in fused state, or whenever or in the aqueous solution, like NaCl, that is sodium chloride, common salt. So it will conduct electricity when it is in molten state or in fused state, or when you put some amount of NaCl into water, so dissolves into water, it will conduct electricity. Okay, so the substances which conduct electricity on molten state or in fused state or in the aqueous solution, and after passing through the electricity, the electrolyte changes and new substances are formed, are known as electrolytes. Okay, so will mercury is an electrolyte? No, mercury is not an electrolyte. Why mercury is not an electrolyte? Because mercury conduct electricity, but mercury doesn't break into these ions, and no new substances are formed after passing the electricity. So that's why mercury is not an electrolyte, whereas NaCl is an electrolyte, because in aqueous solution is broke into different ions. Positive ions are known as cation and negative ions are known as anions. Okay, so one is known as cation and another is known as an anion. So anion is negatively charged and cation is positively charged atoms. Okay, so these are the, or positively charged ions are cation and negatively charged ions are anion. So the electrolytes are the substances which conduct electricity when it is in fused state or it is in aqueous solution, but it also broke into this cation and anion, and that's why after passing electricity new substances are formed. So that's why it is known as electrolyte. Now there are few weak electrolyte and there are few strong electrolyte. So what do you mean by weak electrolyte and what do you mean by strong electrolyte? Suppose a kind of electrolyte which dissociate more in aqueous solution or almost dissociate, like suppose if you put some amount of HCl acid into water, then if there are 1000 of HCl molecules, out of them 950, suppose 900 to 950 molecules dissociate, to produce H plus ion and Cl minus ion. So that's why it is a strong electrolyte. Okay, and in case of weak electrolyte, the electrolyte which in aqueous solution doesn't dissociate more. Suppose there are 1000 molecules and out of 1000 molecule only 500 or 400 to 500 molecules dissociate. At that time we can see, or we can say, it is a weak electrolyte. Okay, so one is strong electrolyte, another is weak electrolyte. Okay, now there is a process which is known as electrolysis. Electrolysis is a process where new substances are formed when electricity is passing through the electrolytes, are known as electrolysis. So electrolysis, or due to the electrolysis, new substances are formed. How new substances are formed? Suppose we do electrolysis of water. So water is a bad conductor of electricity, so it can't conduct electricity, so we need to add a drop or two of some acid or some salt. Okay, so now if we dissociate some amount of salt there or acid there, suppose in case of water, electrolysis of water, or on electrolysis of water is done in a particular instrument which is known as voltmeter. Okay, now let us consider, or let us show the electrolysis of NaCl. Suppose NaCl. So NaCl dissociate into two ions. NaCl dissociate into two ions, Na plus and Cl minus. So whenever electricity pass through the NaCl, so what happen at that time? There are Na plus molecules and there, and Cl minus molecules are there. So there is anode and cathode. So suppose this is anode, so this is positively charged, this is negatively charged. Now this anode and cathode, when it conduct electricity, at that time Cl minus will attracted towards the positive and Na will go towards the negative. Okay, so Na plus will go towards the negative, that is go towards the anode or cathode, go towards the cathode. So this is the cathode reaction. In case of cathode reaction, Na plus go to the cathode, and as it is positive means there is a deficiency of electron. Positive, when positive ion produced, whenever an atom give away electron, so the positive, it is positive means there is a deficiency of electron. So it will go there and take one electron to produce Na atom and deposit there, and Cl minus ion will go to this anode and it will give away one electron to produce, Cl ion, or sorry, Cl atom. Okay, Cl atom. So one Cl atom fuse together or combine together to produce chlorine gas. Okay, so this is the cathode reaction and this one is the anode reaction. Okay, and this is the process of electrolysis. Now in case of electrolysis of water, what happens? In case of electrolysis of water, what happens? In case of electrolysis of water, suppose there is water. So in water, H plus ion, it dissociate into H plus ion and OH minus ion when some amount of acid is added to it. Next, what happens? There is positively charged and negatively charged anode and cathode are there. Okay, so one is positively charged, another is negatively charged. Now what happened? The positively charged H plus will go towards the negative and H plus will take one electron to produce H, hydrogen atom, and hydrogen atom reacts with another hydrogen atom to produce hydrogen gas. So in cathode we will get hydrogen gas. Okay, and in anode OH minus ion will go there and it will give away one electron to produce OH, and this OH again dissociate to form oxygen and water, dissociate to form 4 OH or 4 number of OH added together and produce oxygen and water. So here we will get oxygen gas, O2 gas. Okay, and so the electrolysis of water produce oxygen and hydrogen gas. So you see that after passing through the electricity, it will dissociate and new substances are formed. New substance means oxygen gas and hydrogen gas are formed. Okay, and the volume of hydrogen and oxygen gas 2H2 plus O2 is equals to 2H2O. So that's why two volume of hydrogen will produce here and 1 volume of oxygen is produced on the anode. Okay, so this is the electrolysis of water. Electrolysis, by the process of electrolysis of water, we will get the, or we will break the water to get its component, that is oxygen, and another one is hydrogen. Now another thing, what is the use of electrolysis? Use of electrolysis, there are various use of electrolysis. So one of the main use of electrolysis is electroplating. What is electroplating or galvanization? Electroplating, often you see that there are some gold plated jewelry is there or silver plated jewelries are there. So how the gold plating is done, or what is this gold plating? Gold plating is actually done on the jewelry made up of silver. There is a small, or there is a very thin coating of gold apply on them. So how will you apply? You need to do the electrolysis process. You need to do the electrolysis process, and that process is known as electroplating. That process is known as electroplating. Okay, so in case of electroplating, what you need to do? You need to choose something. First, as an electrolyte, we need to choose the salt or the acid of the substance of which we need, or we are going to electroplate there. So suppose there is an iron nail. Suppose there is an iron nail. Okay, and there is a copper plate, and we need to plate the iron nail with copper. So we need to dissolve copper sulfate salt. What kind of salt? Copper sulfate, CuSO4. As we want to plate this nail with copper, so that's why we need to use copper salt. If we want to make an electroplating of gold, then we need to use salt of gold. Okay, salt of gold, and for silver, salt of silver, and so on. And one thing, connect this. So whenever, suppose CuSO4 is dissolved into water. So if CuSO4 is dissolved into water, then what kind of dissociation happens? So it dissociates into two ions, Cu plus and SO4 2 minus, Cu2 plus and Cu2 plus and SO4 2 minus. So whenever CuSO4 put into water, it will dissociate into Cu2 plus ion and SO4 minus ion. Then you need to connect it with the positive end of the battery, and we need to connect it with connect the nail with the negative end of the battery. So in anode, we need to put the substance whose electroplating, or by which we are doing, or we want to do the electroplating, and on which we are doing the electroplating, or on the substance on which we want the plating is as cathode, and the plate is on the anode. So if you want to electroplate something with gold, then gold should be placed at anode. And if suppose there is a silver spoon and you need to or you want a gold spoon, then you need to electroplate that silver spoon with the gold. So gold need to be placed at anode, that is a gold bar, and at cathode you need to place the spoon. Next, as soon as you conduct the electricity, or as soon as you apply the electricity, or as soon as you close the circuit, at that time current will flow through the solution, okay, and Cu2 plus will go towards the cathode, and it will go towards the cathode and take one electron. How many electron? 2 electron. 2 electron deficiency is there, so it will take 2 electron and it will deposit there as copper atom. And as soon as there is a deficiency of density in copper, deficiency of copper ion, so at that time this copper plate, from this copper plate Cu give away 2 electron and come to the solution as Cu2 plus ion, and this Cu2 plus ion again go to the cathode and take 2 electron and deposit there. So ultimately after some time you will see there the plate just melts, like, or it is a kind of melting, where you will get to see that the width of the plate decreasing, and after some time if there is not enough copper is present, then the copper will finish there and all the copper will deposit there. So this is the process of electroplating. So for today this much you need to learn. So from your book you will go through the book, and if you have any doubt then you can comment on the comment box, and if you like my video then press the like button, and if you not subscribe yet then please subscribe to my channel for the new video, and press the bell icon so that whenever I upload any new video you will get the notification. Thank you, students.